Okay, hello Cloud Gurus and welcome to this lecture. In this lecture, we're going to look at high performance compute on AWS. Now, the great news is it's never been easier to get started with high performance computing than any other time in history. And AWS is obviously the perfect place to perform it because you are going to pay either by the hour or by the second for the resources that you provision. And you can create a large number of resources in almost no time, and you only pay for the resources that you used. And once finished, you can then go ahead and destroy those resources. And high-performance compute is used for industries such as genomics or finance and financial risk modeling, machine learning, you've got weather prediction, and even autonomous driving. So what are the different services we can use to achieve HPC on AWS? And we'll start by looking at data transfer. So how can we get our data into AWS? What are the compute and networking services we can use in AWS? What are the storage services? And then how can we do orchestration and automation? So let's start with data transfer. What are some of the ways we can get our data into AWS? Well, the first way is using Snowball or Snowmobile, and this is terabytes or petabytes worth of data. And this is essentially where you load all your information up into Snowball, you ship it off to AWS. They then use their own internal backbone network to load that data to S3, and then you don't have to transmit it over the internet. We then also have AWS Data Sync to store our information on S3, EFS, and FSX for Windows, etc. And so data sync is essentially we're going to install an agent on a virtual machine, and this could be inside our own data center, inside an on-premise data center, and we're going to push that data up to AWS. And then we have Direct Connect. Now, we haven't covered Direct Connect off in the course yet. We will do that later on in the networking section, but I'll just give you a quick overview of what Direct Connect is. Essentially, it's a cloud service solution that makes it easy to establish a dedicated network connection from your premises to AWS. And using Direct Connect, you can establish private connectivity between AWS and your data center, office, or co-location environment. So basically, it's just a dedicated line from your data center into AWS. And in many cases, this can reduce your network costs, increase the bandwidth throughput because it's dedicated to you, and provide a more consistent network experience than internet-based connections. And again, we will look at Direct Connect later on in the course, in the networking section of the course. So that's how we can move our data into AWS. What are the compute and networking services that allow us to achieve high-performance computing on AWS? Well, we've got our EC2 instances, and these could be GPU or CPU optimized. We then have our EC2 fleets, which we've already covered off, and these could be spot instances or spot fleets. We then have placement groups, and in particular for HPC, we look at cluster placement groups, so we're reducing the latency between our EC2 instances so that they're both very close together, they're in the same availability zone. And then moving down from the compute layer to the network layer, we have this thing called enhanced networking. And enhanced networking consists of elastic network adapters, and we'll have a look at that in a couple of slides. And then we also have elastic fabric adapters. So what is enhanced networking? Well, it uses single root IO virtualization, or SRIOV, to provide high performance networking capabilities on supported instance types. So SRIOV is a method of device virtualization that basically provides higher I/O performance and lower CPU utilization when compared to traditional virtualized network interfaces. So it's just a way of doing virtualized networking that is much faster than your traditional virtual network interfaces. Enhanced networking basically provides you with higher bandwidth, higher packets per second performance, and consistently lower inter-instance latencies, and there's no additional charge for using enhanced networking. And you always want to use enhanced networking where you need good network performance. So enhanced networking comes in two different flavors, and it just depends on your instance type. The most popular and the one you choose in an exam scenario is the Elastic Network Adapter, or ENA, and this supports network speeds of up to 100 gigabits per second for supported instance types. We also have the Intel 82599 Virtual Function, or VF interface, and this is a legacy product. It supports supports network speeds of up to 10 gigabits per second for supported instance types, and it's typically used on older instances. I don't think you will see this in your exam. If you need enhanced networking, look for Elastic Network Adapter. In any given scenario question, you would choose ENA over your virtual function simply because you get much better speed and it's not a legacy product. Now that we've covered off enhanced networking and Elastic Network Adapters, let's move on to Elastic Fabric Adapters. So an EFA, or an Elastic Fabric Adapter, is a network device you can attach to your EC2 instances to accelerate HPC and machine learning applications. And EFAs provide lower and more consistent latency and higher throughput than the TCP transport traditionally used in cloud-based HP systems. And the cool thing about EFAs is they can use this thing called OS bypass, and this enables HPC and machine learning applications to bypass the operating system kernel, and it actually communicates directly with the EFA device. And this makes it a lot faster with a lot less latency, a lot lower latency. It's not supported with Windows currently, it's only supported with Linux. So that's what an Elastic Fabric Adapter is. So now that we've covered off networking, let's look at storage services that can allow us to achieve HPC on AWS. And we've got instance attached storage. So this can be things like EBS, and this scales up to 64,000 IOPS with provisioned IOPS. We've also got instance store. So this is where you've got ephemeral workloads, and it can scale to millions of IOPS with low latency. Moving on, we've got network attached storage. So we've got S3, and this is distributed object-based storage. It's not a file system. If you do need a file system, then use Amazon EFS, and this scales IOPS based on the total size of the file system, or you can also use provisioned IOPS with EFS. And then we have Amazon FSx for Lustre, which we covered off a few lectures ago, and this is a HPC optimized distributed file system, gives you millions of IOPS. And the cool thing about this is it's also backed by S3. So now that we've covered off networking and storage, we're going to move on to orchestration and automation. So what are the orchestration and automation services that allow us to achieve HPC on AWS? Well, there's really two. And the first one is AWS Batch. This enables developers, scientists, and engineers to easily and efficiently run hundreds of thousands of batch computing jobs on AWS. AWS Batch supports multi-node parallel jobs, which allows you to run a single job that spans multiple EC2 instances, and you can easily schedule your jobs and launch EC2 instances according to your needs. And then the other automation or orchestration service that we use is AWS Parallel Cluster, and this is an open source cluster management tool that makes it easy for you to deploy and manage HPC clusters on AWS. And the way it does this is it uses a simple text file to model and provision all the resources needed for your HPC applications in an automated and secure manner. And it allows you to automate the creation of VPCs, subnets, cluster types, and instance types. And we're going to cover off VPCs and subnets later on in the course in the VPC section of the course. So onto my exam tips. Basically, let's just rehash everything we've just learned. We can achieve HPC on AWS through doing data transfer, through compute and networking, through storage, and then through our orchestration and automation services. We start off with data transfer. Just remember, if you're going to move large amounts of data into AWS, you're going to be using Snowball or Snowmobile, and that's physically copying it from your location, shipping it off to the AWS data center where they will then load that for you. We can also use AWS Data Sync to store our files on S3 or EFS or FSx for Windows as well. And then we can also use Direct Connect, and we're going to have a Direct Connect lecture coming up in the VPC section of the course, but essentially it's a dedicated line into the AWS data center. On the compute and networking fronts, we can use EC2 instances that are GPU or CPU optimized. We can use EC2 fleets, so either spot instances or spot fleets. We can use placement groups, and in particular cluster placement groups, so they're all within the same availability zone, which gives us that super low latency. We can use enhanced networking single root IO virtualization, or SRIOV, or we can use our Elastic Network Adapters or our Intel 82599 virtual functions. given the choice in a scenario question, you're always going to use the Elastic Network Adapter because the Intel VFs are legacy. And besides, you get 100 gigabits per second with your Elastic Network adapters as opposed to 10 gigabits per second with the other ones. And then, of course, you can also use your Elastic Fabric adapters, which have the OS bypass. Moving on to storage, so we've got our instance attached storage. So we've got EBS, which scales up to 64,000 IOPS with provisioned IOPS. We've got our instance store, which scales to millions of IOPS and has very low latency. We then have our network storage. So we've got S3, which is a distributed object-based storage. So it's not a file system. If you need a file system, let's look at Amazon EFS, and this scales IOPS based on the total size, or you can use provisioned IOPS. And then we've got Amazon FSX for Lustre. This is HPC optimized distributed file systems with millions of IOPS, which is also backed by S3. And then just remember going into the exam, our two different orchestration and automation services, AWS Batch and AWS Parallel Cluster. So that is it for this lecture, everyone. If you've got the time, please join me in the next lecture. Thank you.